Good evening, everyone. I welcome you all in this session of question discussion kinetic theory of gases. We have recently covered this topic in the Enable Plus class, and now here we are to cover the question portion of it. We will be solving questions one by one, and you will also going to solve it, and then let me know it's solvable or not. Okay, and I'll be helping you out. So let's just start with the very first question here. The temperature of a gas is minus 78 degrees Celsius and the average translational kinetic energy of its molecule is K. The temperature at which the average translational kinetic energy of the molecules of the same gas become 2K. So initially it is given as K at this particular temperature and finally it become 2K. So we have to find out that temperature. Now we know that translational kinetic energy of a gas is nothing but 3 by 2 times kb into t. This is the translational kinetic energy kt. Now in this process we know, or according to this formula we know, that kinetic energy is directly proportional to the temperature, but that temperature should be on a scale of Kelvin. It should be given in Kelvin scale. The given temperature that is given to us is in Celsius. So firstly we need to convert this temperature. We can write it as like K1 by K2 is equals to T1 by T2. Okay. Now T1 is given you as minus 78 degrees Celsius. You have to convert it into Kelvin. Minus 78 plus 273. Okay. If you calculate it, it will become 13 minus 8 will become 5. Okay. This will become 6. 6 minus 7 will become 9. 16 minus 7, 9. And it is 1. So this is coming out as 195. Okay. 195 Kelvin. Now K1 is nothing but K at what temperature? 195. Clear? Divided by T2 we want to know. And that final kinetic energy will become 2K. This K and K will cancel out. So T2 will become 2 times of 195, which is nothing but 0. 390 Kelvin. But this temperature is given in Kelvin. Now answer is mentioned in the Celsius scale. So you have to again convert it into Celsius. So it will be, you have to subtract 273 in it. 390 minus 273. Now you know that 10 minus 3 is 7. Okay. Here it will become 8. 8 minus 7 is 1. So 1 7 is only in this option D is the correct. Any kind of doubt, guys, in this question? Any kind of doubt you are having? Make sure that each concept and process is clear to you. Now the second part. Try to solve this question. I'm giving you 1 minute to solve this. Mixture of 1 mole of monoatomic gas and 1 mole of diatomic gas, which is resid, are kept at room temperature, which is 27 degrees Celsius. The ratio of specific heat of a gas at constant volume respectively. So try to solve this question. I'm giving you 1 minute to solve this. Okay. After that, I'll be solving this part. So I think I've given enough time to solve this question. Let's just try to solve it. A mixture of 1 mole of, and all of these questions are previous year JEE in 2024. Okay, so this is going to be really important for you. Mixture of 1 mole of monatomic gas and 1 mole of diatomic gas, which is rigid, are kept at room temperature. So temperature is given to you as 27 degrees Celsius. You have to convert it into Kelvin. 27 plus 273, which is 300 Kelvin. Now, if the gas is monoatomic, we know that Cv for the monoatomic gas is 3 by 2 times of R. Okay? And for Cp, Cv is equals to, for diatomic gas, it will be 5 by 2 times of R. Now, it can be 7 by 2 if the molecule of the diametric gas is non-rigid. But if they are rigid, which means they cannot have the vibrational degree of freedom. So vibrational degree of freedom, we cannot have them. Okay. So this rigidity of diatomic gas molecule possess a CV, which is specific heat at constant volume, is 5 by 2 times of R. Now if you take the ratio of it, this is for monoatomic, this is for diatomic. So we can say CV of M upon CV of D is equals to 3 by 2 divided by 5 by 2. This will be 2 by 4. Will become 3 by 5. So option B is the correct one. I hope that you don't have any kind of doubt in this. Are you getting it? Am I audible to everyone? Let me know in the chat box. Okay, then move ahead with the next question, which is this. Energy of 10 non-rigid diatomic molecules at temperature T is. So first of all, in solving these types of question, you have to check whether the molecule given to you is non-rigid or rigid. So in this question, if you see non-rigid diatomic molecule is given to you. Now, we strictly talk about the degree of freedom of a gas. And in terms of degree of freedom, total energy is given by F by 2 kb into T. Okay. Now, if the degree of freedom is 5, then energy will become 5 by 2 kb into T. If degree of freedom is 7, then energy will become 7 by 2 kb into T. Okay, this is. Now, if this is a diatomic molecule, which means we have two molecules, dumbbell. And if it is a non-rigid, then it can vibrate. These molecules can vibrate along the line joining them, along its bond length. Okay. Due to that, they will possess one extra degree of vibrational kinetic energy, and one is for vibrational potential energy. So total degree of freedom of this molecule will be 7. This is the DOF of diatomic molecule, which is non-rigid. Now we have given by 10 molecules. So energy of single molecule will become 7 by 2 times kb into T. So this is for the single molecule. Single molecule. Okay. Now for 10 molecule, energy of 10 molecule become 10 multiplied by 7 by 2 kb into T. So this will become what? 5. So E of 10 molecule will become 35 kb into T. So this is option D is the correct answer. Now, any kind of doubt in the previous question? Let me know. JNV and JNV Ukrul. Now try to solve this one. A total of 48 joule heat is given to 1 mole of helium kept in a cylinder. The temperature of helium increased by 2 degrees Celsius. The work done by the gases given R equals to 8.3 joule per Kelvin per mole. So the value of R is given to you as 8.3 joule per Kelvin mole, and total heat that we have given to the system is 48 joule. And this heat is given to 1 mole of gas, which means N is 1, and this gas is nothing but helium. Got it? Now the temperature of helium gas is increased by 2 degrees Celsius, which means delta T is given as 2 degrees Celsius. Now whenever it is change in temperature, so the scale will be same. If you convert this into Kelvin, it will come out as same, 2 Kelvin. And this is only possible for Celsius to Kelvin scale. Okay? 2 degrees Celsius change of temperature will be same in the Kelvin scale, 2 Kelvin. Okay? Now, if you apply this equation, we know the thermodynamics law, which is delta Q is equals to delta U plus W. Delta Q is given to the system, so it will be positive, which is 48. Delta U we can calculate. Delta U is nothing but N CV delta T. Now N is given to you as 1. CV, this is for a helium is what? Helium is a monoatomic gas. देखो He2 तो नहीं होता ना, He होता है. So monoatomic gas. So it will be 3/2 times R. And to delta T is 2. This and this will cancel out, so it will become 3 times of R, which is 8.3. ठीक है? 3 3 is 9 and 3 8 is 24. 24.9. Now this is 24.9 plus W. Now W will be 48 minus 24.9. So it will become what? 920. Give me a moment, guys. So here we are. So in this question, what we are doing here, we have calculated the internal energy of the system, which is nothing but NCV delta T, 24.9, and we have put it in the first equation of thermodynamics, first law of thermodynamics, which is delta Q is equals to delta U plus W. So by this equation, we are able to find out the work done, which is 24.9 joule. Okay, so option C is the correct one. Any kind of doubt you are having, anyone? This one, the specific heat at constant pressure of a real gas obeying PV square is equals to RT. Okay, the gas is given as PV square equals to RT. So we have to find out the specific heat at constant pressure, which means CP we have to find out. Okay, for CP we know that CP is nothing but delta Q is equals to, देखो CP के लिए we know that CP minus CV is equals to R. So if we are able to find out CV, then CP is nothing but R plus CV. And CV we know is nothing but N CV is equals to du is equals to NCV delta dt. So we have to find out the internal energy of the system. That's why we are able to calculate the CV. Now if you differentiate this, write the differential form of it, it will become P into 2V dV, differentiation of V square, 2V into dV, plus then differentiation V square remain as it is, differentiation of pressure will be dP, it will become R dt. Okay, now we know that this heat is at constant pressure, the specific heat at constant pressure, so this PP term will become 0. If the pressure is constant, there is no meaning of this dP, so it will become 2 times of PV dV is equals to R dt. ठीक है. Now we know that the first equation of heat transfer of thermodynamics law is dq is equals to du plus dw, which is the work done. ठीक है. Now dq is nothing but we can write it as ncp dt. Du we can write it ncv into dt, and dw is nothing but p into dv. तो यहाँ से आप देख सकते हो p into dv is nothing but r by 2 times of v dt. This is the value from this equation. Now if you put it here, so it will become ncp dt is equals to ncv dt. Put down the value of pdv. It is r by 2v into dt. Now dt will cancel out from both the sides, and this will become n will also you can cancel out. This would be also n times of this. So n will also you can cancel out. So from here you can say Cp is coming out as Cv plus R by upon 2. ठीक है. And this is the value of specific heat at constant pressure, which is Cv plus R by 2 times of. So option C is the correct. Okay. Now move on to the next one. Thus, a sample contains mixture of helium and oxygen gas. The ratio of root mean square speed of helium and oxygen in the sample is. Now we know that VRMS of a gas is nothing but 3 by 3 RT upon M naught, where M naught is the molecular mass of the gas. It is the molecular mass of gas. Okay. Now, if we write the VRMS equation for oxygen, it will be written as VRMS of oxygen O2 is 3 RT upon MO of oxygen. Now VRMS for helium, square root of 3 RT upon mass of helium. If you take the ratio of it, it will become VRMS of O2 divided by VRMS of He is equals to square root of M of He upon M of O2. Now VRMS of O2, we have to find out the ratio. So mass of hydrogen, this is the molecular mass. So molecular mass of helium will be what? 2 is to 4. So molecular mass of helium will 4 divided by M of O2, it will be 32. So it is coming out as 1 by 4. ठीक है, clear? So option B is the correct one. Now try to solve this one. Try to solve this one. ठीक है, अब देखो, if n is the number density and d is the diameter of molecules, then the average distance covered by a molecule between two successive collision, और इस एवरेज डिस्टेंस को हम क्या बोलते हैं, मीन फ्री पैथ, इज रिप्रेजेंट बाय, सो मीन फ्री पैथ which is represented by lambda for any gas is given by 1 upon root 2 n pi d square, where n is equals to number density of the molecule, number density of molecule, and d is the diameter of molecules. Okay? So this is the mean free path. Now option A is the correct. 1 upon root 2 n pi d square. Okay? Look how simple question is being asked in JEE. Now, if the collision frequency of a hydrogen molecules in a closed chamber so if the collision frequency of hydrogen molecules in a closed chamber is 27 degrees Celsius is Z, then the collision frequency of the system is 1 at 127 degrees Celsius. देखो ये नया क्वेश्चन हो सकता है. Collision frequency हमेशा याद रखना. Z is given by Z naught square root of T1 upon T2. Because we know that collision frequency is directly proportional to the square root of temperature. Okay. So Z by Z naught is equals to square root of T1 by T2. Now, T1 is the temperature for Z naught and T2 is the temperature for Z. Now we know that, and this temperature you should be remaining, you should put in absolute scale, which is Kelvin. So initially T1 is given to you as 27 degrees Celsius. In Kelvin scale, it will become 300 Kelvin. And T2 is given to you as 127 degrees Celsius. So definitely it will become 400 Kelvin. Now Z upon Z naught at 27 degrees Celsius, it is Z. So we will say that Z final upon Z initial is what? Z equals to square root of T1, which is 300 upon 400 equals to square root of 3 by 2. So Z final is nothing but Z root 3Z by 2. Okay. So option is the correct option. Now, the translational degree of freedom Ft and rotational degree of freedom Fr of CH4 molecule is. अब देखो यहाँ पे थोड़ा सा आपको केमिस्ट्री का पोर्शन यूज करना पड़ेगा. CH4 मोलिक्यूल्स जो होता है, दिस इज अ नॉन लीनियर मोलिक्यूल. नॉन लीनियर मोलिक्यूल्स. ठीक है. दिस इज व्हाट अ नॉन लीनियर मोलिक्यूल. The translational degree of freedom. So we know that for a non-linear molecule, so this non-linear molecule will not lies on the axis, any axis. It will be CH4, which means rotational variables. If you try to rotate this molecule in any axis, apart from any three axes, it will take the rotation in any three axes, which means rotational about x-axis is also possible, rotation about y-axis is also possible, and rotation about z-axis is also possible. So rotational degree of freedom of this molecule will be 3. Translation तो ये कर ही सकता है, x के along भी, y के along भी, z के along. So translational degree of freedom is also 3. So total degree of freedom here will be 6. But the rotational, the translational degree of freedom represented by Ft, which is 3. And rotational will also 3. So option B is the correct answer. Now, if the root mean square velocity of hydrogen molecule at a given temperature and pressure is 2 km per second, the root mean square velocity of oxygen at the same condition in kilometer per second is. So try to solve this question. I'm giving you 2 minutes to solve this question. So I think you are not solving it. So root mean square velocity of hydrogen molecule is given at a given temperature and pressure. Root mean square velocity of oxygen at the same condition in kilometer per second. So we know that again the same concept we are going to use. VRMS of hydrogen, VRMS of oxygen is nothing but square root of, if the temperature is same, then only the molecular weight will be the responsible factors. Now, VRMS of hydrogen is given as 2 kilometer per second. VRMS of oxygen gas you have to find out. Oxygen gas का molecular weight is 32 and hydrogen gas का molecular weight is 2. So it is 16, which is nothing but 4. So 2 upon V molecular, V of oxygen equals to 16. And root of 16 will be 4. So it is coming out as 2, which is nothing but 1 by 2.5 kilometer per second. So option D is the correct. Okay. Now move on to the next one. Okay. So this is it for today's class. I hope that each and every concept is clear to you and you must have gone through all these questions with me. So if you have any kind of doubt, you can ask right now. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive. No, you are not being responsive in the lecture. Thank you so much for the attention. Bye bye. Take care of yourself.